Okay, today we're going to be talking about something completely new, and that's called a compound inequality. And a compound inequality is just more than one inequality in one statement. So what I'm going to have is multiple inequalities, usually two inequalities, but within the same single statement. So if I look at the number lines that I gave you, the first number line says x is greater than or equal to 3, because all the numbers that are greater than 3 are shaded and it's a closed circle. In the second number line is x is less than or equal to 7, because I have a closed circle and I'm shading all the numbers that are less than 7. If you notice in the third line, the shading only goes between 3 and 7. So that means that the x, or the value that x can be, is somewhere between 3 and 7. So I put the x in between the 3 and 7. Now, this part of the number line says that the x has to be less than or equal to 7. But this part of the number line says that the x has to be greater than 3. Or in other words, the 3 is smaller than or equal to whatever x is. Now, this is a compound inequality here. Notice we have two inequalities with one statement. But the key is we always have to have the inequalities pointing to the left. In other words, your inequalities are always going to be less than or equal to signs. You're not going to have one inequality saying less than and the other inequality saying greater than. That's not allowed with a compound inequality. If I look at the other inequalities on the right, the first inequality says x is less than -2. The second one says x is greater than or equal to 1. But if you notice on the third number line, the shading goes off in two different directions. So on the left-hand side, I have x is less than -2, or on the right-hand side, I can have x is greater than or equal to 1. So this is another compound inequality. There's two inequalities, but I have one statement joining with an or. The word or joins them. So what we have is either a situation where the shading is going to go between two numbers, or the shading is going to go out in either direction. So let's take a look at what how these compound inequalities are used. We're going to write the set builder notation in words and then graph. X, now this bar right here means such that. And this is saying that x is in between -2 and 6, and x is any real number. So to say this in words, or better words, we would say x is a real number that is in between -2 and 6, but not including -2 and 6, because I have less than signs, not less than or equal to signs. So x can be any number in between -2 and 6, but not including -2 and 6. So to put it on a number line, I'm going to have -2 on the number line all the way up to 6. And remember, you can count by whatever you want to count by. You can count by 1s, or you can count by 2s, or you can count by 3s. I chose to count by 1s. Now, I'm going to have an open circle at 2, because this says 2 is less than x. So I'm going to have an open circle at 2. And then I'm also going to have an open circle at 6, because it says x is less than 6. And because my x is in between the -2 and 6, my shading is going to be in between -2 and 6. So I can have any real number in between, but not including -2 and 6. Okay, for the second one, it says x, remember this bar means such that. So x such that x is less than 0 or x is greater than or equal 5, where x is any real number. So x is a real number such that x is less than 0 or x is greater than or equal to 5. X can be any number that's less than 0 or greater than or equal to 5. So I'm going to have both 0 and 5 on my number line. And again, you can count by whatever you want. I'm going to count by ones again. Now, at 0, I'm going to have an open circle. And at 5, I'm going to have a closed circle. The first inequality says that X has to be less than 0. So I'm going to shade all the numbers that are less than 0. And the second inequality says X is greater than or equal to 5. So I'm going to shade the numbers that are greater than or equal to 5. So this is another compound inequality. So if you notice that in a compound inequality, your shading is either going to be between two numbers or the shading is going to go out in either direction. Okay, let's try some solving compound inequalities. Okay, a solution of a compound inequality involving an and, that's where the shading is in between, is any number that makes both the inequalities true. In order to solve a compound inequality, we're going to get the variable alone, doing the exact same process I use for solving equations, but what we're going to do is we're going to do the inverse operations on all sides of the inequality, all sides of the inequality. So in number 2, it says, what are the solutions of -3 is less than or equal to m minus 4 is less than -1? And then we're going to graph the solutions. Now, we want to focus on the m minus 4 part, because remember, I want to get the variable by itself. So what I'm going to do is I'm going to add 4, but I'm going to add 4 to all 3 sides. So I'm going to add it to the left. I have adding 4 in the middle and adding 4 on the right. -3 plus 4 is 1, less than or equal to m, less than -1 plus 4 is 3. Now, notice that the m is by itself. If the m is by itself, I'm done. I finish the inequality. This is saying that m, or the variable, has to be between the numbers 1 and 3. So on my number line, I'm going to have 1 through 3. I'm going to actually start with 0 and count by a half. So 0, 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4. So I just skipped every other line because I was counting by halves. Now, I'm going to have 1 as a closed circle and 3 as an open circle. And my compound inequality says that m has to be between the two numbers. So my shading is going to be between the two numbers on the number line. So m is any real number between 1 and 3. It can include 1, but it can't include 3. Okay, number 3. This is an actual Regents exam question. Given x such that x has to be between -2 and 6, where x is an integer. Now this time I'm only looking at the integers, meaning no fractions or decimals. So my answers can't have fractions or decimals. It wants to know the solutions of 5 is less than 2x plus 5 is less than 13. Now again, we're going to focus on the variable. And when I'm solving equations, I get rid of the addition or subtraction first. So I'm going to subtract 5 first. But remember, I'm going to subtract it from all of the sides. So in 3 places, I'm going to subtract. 5 minus 5 is 0, is less than 2x, is less than 8. Now the x is not by itself. It still has multiplied by 2. So I'm going to divide everybody by 2 to get rid of the 2. 0 divided by 2 is 0. Less than x, less than 4. Now, if you were taking this on the Regents exam, you would only get 50% of the question right, because remember it says that x has to be an integer. And this is saying, this compound inequality is saying that x can be any number between 0 and 4, not including 0 and 4. Well, because x has to be an integer, those are positive and negative whole numbers, x can only be 1, 2, or 3, because those are the integers between 0 and 4, not including 0 or 4. I put my answers in a set of braces just because I want you to see it as a solution set. The braces just show me that it's a set of numbers, then those are the possible answers that will make the inequality true. Okay, I'm going to pause the video. What I want you to do is I want you to read the question, I want you to think about it a little bit and see what you can come up with. When you come back to the video, I'm going to have something written on the board. Okay, this question is basically asking, what do I need on the fourth test? Now, when they say fourth and final test, it means that the fourth test is the final test. What do I need on that fourth test to earn an average or to get a B in the course? So I have my let statement. Let X equal the score that I need to get on the fourth test. And what the question is saying is, in order to get a B, I need to be between 84 and 86 with my average. So I put my average between 84 and 86, inclusive, meaning I can include the 84 and 86. Now you have to think back to high school or to middle school to remember how to do an average. To find an average, we have to add up the scores, and that fourth test that I don't know, divide by the number of tests there are. Okay, now, since we can't put a variable in the calculator, we're going to add the three values together, 86 plus 85 plus 80. So I'm going to get 84 is less than or equal to 251 plus x over 4 is less than or equal to 86. Okay, now a lot of people, what they're trying to do is you're trying to divide 251 by 4. You do not want to do that. You're not allowed to divide 251 and 4. What you're going to do to get rid of this division of 4 is you're going to multiply by 4. But remember, we have to multiply everybody by 4, just like we have to add or subtract all sides. So we're going to do 84 times 4, which is 336, is less than, now these 4s will cancel each other out. When you're multiplying and dividing by the same number, they reduce to 1. So you're left with 251 plus x is less than or equal to 364. Now if we look at the x, we want to get the x by itself. So because there's a positive 251 with it, I'm going to subtract 251 on all sides. And when I do that, I'm going to end up with 85 is less than or equal to x is less than or equal to 93. That means that I need to get somewhere between an 85 and a 93 on my last test in order to have a B average. Now, I'm actually going to skip number 5 for the sake of time, and I'm going to go right on to number 6. Okay, a solution of a compound inequality involving OR is any number that makes either inequality true. So it's either going to make one inequality true or the other one. It doesn't have to be both. To solve a compound inequality involving OR, you must solve separately the two inequalities that form the compound inequality. So in number 6, it says, what are the solutions of 3t plus 2 is less than negative 7, or the inequality negative 4t plus 5 is less than 1? Then we're going to graph our solution, and we're going to write it in interval notation. Now, these are actually kind of nice because they're just two completely separate inequalities that we're solving. I'm going to come over here to the first inequality. I'm going to subtract 2 from both sides. So I get 3t is less than negative 9. I'm going to divide both sides by 3. I'm not going to flip the inequality sign because I didn't divide by a negative number. So I'm done with that inequality, and now I go to the other one and solve the other inequality. I'm going to subtract 5 on both sides, and I get negative 4t is less than negative 4. I'm going to divide both sides by negative 4, and because I am dividing by a negative this time, I'm going to flip the inequality sign. Now, I have two separate inequalities that I'm going to graph on a number line. The first one is saying that t is greater than or less than negative 3. So I'm going to put negative 3 on my number line with an open circle shaded left because I'm going to shade all the numbers that are less than negative 3. And the other one says t is greater than 1, so I'm going to put 1 on my number line. So negative 2, negative 1, 0, 1, 2. 1 is going to have an open circle, and I'm going to shade that to the right for the numbers that are greater than 1. And then the last thing I have to do is write it in interval notation. So because I have two separate inequalities, two separate pieces of the number line, I need an interval notation for the left-hand side, and I need an interval notation for the right-hand side. On the left-hand side, I shade all the way down to negative infinity. So the smallest shading I'm going to have is negative infinity. And I stop shading for this one at negative 3. Both of them are going to have parentheses because infinity always has a parenthesis, and negative 3 is an open circle. Or, for the second side, The shading starts at 1 and shades all the way to positive infinity. And again, both are going to be parentheses because it's an open circle at 1. Okay, now that we're finished with the notes, you're going to work on your homework, and I will be checking it on Monday when we return.